This is a lecture on 11-1, Test for Goodness of Fit. The chapter 11 is called Other chi-square Tests, meaning the book actually talked about some of the chi-square to start with. But for us, this is our first chi-square test. This is a letter chi. It's going to be spelled something like this. But we're going to square it, so it's chi-squared. The distribution looks something like this. So it is no longer symmetric with respect to the 0. It actually starts at a 0, kind of climbs its way up, and has a tail on the side. So we're only going to be talking about a one-tail test. In particular, this is your chi-square distribution. And all of the chi-square tests are one-tailed, right. So only you have one tail on that side. So the test for goodness of fit allows you to see if there is a different number in a category than expected. So we're going to be running two, I'm going to give you two examples. One that has to do with everybody being the same, and the other one is a slightly different expectations with respect to the percentiles. So this is what you may encounter in your book. Now before we get there, let me give you some formulas and assumptions. We must have a random sample. That one's going to be assumed every single time. And number 2, the expected frequency in each category must be 5 or more. The chi-square test statistics can be found by finding the difference between observed and expected, square that, and divide by the expected, where O is observed frequency, and E is the expected frequency. All right, this is where we can start our first example. Let me just move this just a little bit down. My first example is 11-1. What we have is a researcher wants to see if there's a difference in the number of arrests in a certain city for 4 types of crimes. A random sample of 160 arrests shows the following distribution. So the distribution is given to you. We're talking about 4 different types of crimes. Larceny, theft. We managed to observe 38 of those. We have property crimes. We have 50. Drug use. We observed 28. And driving under the influence, so DUI. I don't think this is a complete distribution, but these are the 4 that we're analyzing this time around. What we know is a random sample of 160 arrests showed this particular distribution. So this is my O. This is the observed. What we need to do is we need to create the expected. The expected has to do with the phrase, the original phrase of the problem. And it says a researcher wants to see if there was a difference in the number of rests. So if I have n is equal to 160 and I'm analyzing 4 categories, and I do not want to see any difference between the numbers in the 4 categories. The 160 would be split up evenly into 4 categories. So if you take 160 divided by 4, you will get 40 as the expected value for each of these. All I did is just take 160 divided by 4. Now what we need to do is we need to calculate the chi-square test statistic. The formula says that you need to add up all of the difference between O and E squared, because we don't want to make a difference between negative and the positive signs, otherwise they'll cancel each other out and we don't see any difference. So we're squaring those. This is why the distribution is chi-squared, because we're looking at the squares. And this is probably the only formula that I'll actually write out for you, because the people with the TI-83, you will find that this test is not in your calculator. So the test is called the chi-squared GOF test, and I will guide you through the calculator on the next video for the TI-84 people. Now, as far as the TI-83, this is for you and for anybody who wants to see how this formula lays out. You have O minus E squared, so basically I'm finding the difference between 38 and 40. That's a 2. I need to square that, that's a 4, and divide it by 40. I'll take the next one. I have 50 minus 10, that's a 10 squared, that's 100 over 40. And then you have 28 minus 40, that's a negative 12. If I square that, I get 144. And the last one is 44 minus 40, which is a 4. You square that, you get 16. All I'm doing at this point is putting all of this into my calculator. 4 over 40 plus 100 over 40 plus 144 over 40 plus 16 over 40. 6.6. Now the 6.6 is a test statistic. What you can do after this, especially the people, let me just move this a little bit, especially the people who do not have a TI-84, you could compare this to a critical value. You can look that up in a table if you'd like. I can show you in the class. Or you can figure out a p-value that corresponds to this particular test statistic by using a chi-square distribution. So what you need is you need to go into the second var. So you need to go into your distribution. What you need is you need number 8, at least it's on my calculator. It's a chi-squared CDF. It's basically going to ask you for the lower limit. You want 6.6. It's going to ask you for the upper limit, which in this case must be infinity, because we're trying to get the tail working. So let me draw this picture. So it's going to go look like this. And this is, I found that this is 6.6. If I find the probability of this tail, this will give me that alpha. Oh, I'm sorry. This will give me the p-value. Something that I forgot to mention, this distribution has a degree of freedom. Let me enter it right about here. The degree of freedom is the number of categories minus 1. Let me write like this. Minus 1. So in this case, the degree of freedom, I have 4 categories. Subtract 1 from that, that's a 3. So your calculator is going to ask for that. So what you need to put is you need to put the lower bound, upper bound, the degree of freedom, and what it'll spit out is the probability of that tail, which is your p-value. So the p-value is given to you at 0.0858. What you can do at this point is use the alpha of 0.05. So this one is greater than 0.05 alpha. And just like in previous problems, we will reject or do not reject the null hypothesis. In this case, because the alpha is greater, the p-value is greater than your alpha, so you can always think of it like this in the picture. So what you found is that this area, let me not use the blue. What we found is the p-value is 0.0858, so just about 8.5%. But my alpha is 5%. So this is the shaded region that I'm interested in. That's my alpha. So with this would be the critical value. So the 6.6 lands into the body of the problem. So the p-value is greater than alpha. Will give you the statement of do not reject the null hypothesis. And then if you take a look at the null hypothesis, which I did not write, so let's include that. The null hypothesis in all of the problems of chi-squared, the null hypothesis states there is no difference. And then you say there's no difference in what? There's no difference in the number of crime arrests of each type. In the number of arrests in each type. Of crime. Now, the alternative hypothesis would always state that there is a difference. Now, if you go back to the original definition of what a null hypothesis and an alternative hypothesis are supposed to state, you'll see exactly that statement, that the null hypothesis that there is no difference, and the alternative hypothesis is therefore there is a difference. You're basically copying over what you stated in the null hypothesis. In the number of arrests in each type of crime. So if you do not reject the null hypothesis, we have found sufficient evidence to state that there is no difference in the number of arrests of each type. So that's what you can state. We have found enough evidence Let me rewrite this sentence just a little bit. Let me go back to see how it states. Is there enough evidence to reject the claim that the number of arrests for each category of crimes is the same. So did we find enough evidence to reject the fact that they're the same? And since we say do not reject, that's what you have. And if anything, this is the place for the double negative, because we didn't prove that there is no difference. In fact, if you take a look at the numbers, 50 is almost doubling the 28 property crimes versus drug use. Yet statistics on this level showed that there is no difference. So what we have done is we didn't prove that there is no difference, we just didn't manage to disprove that statement. So this is how we're going to do so this is a better way of writing down the sentence. Now I'm actually looking at the book for this. There is not enough evidence to reject the claim that there is no difference in the number of arrests for each type of crime. Alright, I apologize for not following the steps in the same order, but we will look at this example again, and I will show you how to do this on the calculator in the next video, and the video after that will follow through with the other example.